Hi friends, welcome to GMK tutorials. In this video, we are going to discussing about the NMOS NAND gate realization. That means by using a NMOS transistor, we can realize the NAND gate operation. So before entering into this topic, first of all, what is meant by NAND gate? Alright, so that is the basic, right? So A is the input and B is the one more input. NAND output is equal to generally 0 0 0 1 1 0 1 1. So output 1 1 1 0. This is a NAND gate, right? Suppose మనకి ఇలా అవుట్పుట్ ప్రొడ్యూస్ చేయాలి అంటే కంపల్సరీ వాట్ ఇస్ ద క్రైటీరియా whenever any one of the gate is activated at the time it must be on condition. So but in this video I am going to take a one consideration, that is nothing but NMOS NAND gate realization by using a depletion NMOS is a pull-up device and enhancement NMOS transistors are used as a pull-up pull-down devices. So let us see the scenario here. It is a VDD, so it is a depletion type, so that's why I can representing some marking like this for identification purpose. So some NMOS transistors are connected in this fashion. So let it be considered. Okay, so this is nothing but first one, second one, so on. This is nothing but nth one for understanding. Okay, let it be considered like that. So it will be connected to the source terminal and at the same time we will take the output across this terminal. This is nothing but this is a circuit diagram. It represents the realization of the NAND gate by using a NMOS transistors, right? So we know that generally if you want to work NMOS transistor as an inverter, NMOS acts as a inverter, but it must be satisfied the 4:2 ratio of the corresponding to resistance. So we know that generally each and every NMOS transistor is also called as a resistance. So from this diagram I can take this pull-up device, that is nothing but depletion NMOS transistor as well as enhancement NMOS transistor is also act as a resistors. So from this diagram I can represent the resistance format can be represented in the form of impedances like this. So every depletion mode transistor is also produces gives some pull-up impedance, as well as remaining NMOS transistors are also act as some impedance. I will consider as a ZPD, is a pull-down impedance of the corresponding transistor like this. This is the scenario, right? So ZPD is nothing but pull-down transistor impedance. So if you are taking it is all or in consideration, I will take the output, right? If you are taking in this consideration according to the voltage divider rule, if you are taking some voltage drop across this one, voltage across the corresponding voltage drop across the corresponding resistance by total resistance into corresponding source volt. So these are all ZPD up to n. Let it be considered 1 2 3 so therefore total impedance is equal to n into ZPD, right? So this is a from this voltage divider rule, supply voltage VDD into corresponding resistance value is equal to n into ZPD. Ante total n impedances unnai kada series lo. See, this is called as a series fashion, right? Suppose if you are taking a resistance of 1, so this is what happened: 1 ohm, 1k, 2k, total resistance is equal to 3k. So it is also same fashion, right? These are all in series. So total resistance is equal to n into ZPD. Therefore by n into ZPD plus ZPU, it must be equal to, this ratio must be equal to less than that of 0.2 of VDD. Why? Because this NMOS transistor produces the zero weak output, zero weak voltage. That means which cannot be reduced to final, it cannot produce the complete output. If you observe the characteristics of in case of the NMOS transistor, it produces like this only. This is generally called a VOL. This is nothing but VDD minus VTH. That means NMOS transistor maintains a strong high output and weak low output. So this low output, okay, this low output must be less than threshold voltage of the transistor. So that is the minimum criteria. If you otherwise the corresponding transistors are going to be activated. That means in case output of the circuit can be used for the next one as the input. At that time, this low voltage is greater than threshold voltage. There may be a chance of that transistor is also going to be on condition. So for that purpose, this complete voltage must be less than that of the threshold voltage. So that is the minimum criteria అండి. Threshold voltage కంటే ఎప్పుడైతే తక్కువ ఉంటుందో అప్పుడు మాత్రమే ఇది it acts as a inverter. So దాన్ని యాక్ట్ చేయాలంటే VDD get cancel. What happens is that n times that of the ZPD is less than or equal to 0.2 of n into ZPD plus ZPU. So from this I will represent if you are taking 0 point of n into ZPD is less than or equal to ZPU, right? So this value is equal to 0.2 times that of, if you are writing this one, it is also 0.2 of ZPU. So from this we can get 0.2 is the 4 times that of, therefore 4 n into ZPD is less than or equal to ZPU. So from this diagram, ZPU by n times that of so from this diagram, so what is the value? ZPU is equal to pull-up resistance by n into ZPD is greater than or equal to 4. So moreover, it is also can be represented as ZPU is greater than or equal to 4 times that of n into ZPD. So we know that in case if the NMOS transistor is used as a in case of the NMOS transistor, passive resistor is used as a pull-up device. At that time, the compulsory the NMOS transistor must satisfy the RL value is greater than the 4RC. So this is a minimum criteria. Whenever this criteria is satisfied, at that time only the corresponding inverter is act as a transistor act as an inverter. So from this diagram, it is very clear. Okay, NMOS NAND gate realization using a depletion MOSFET is used as a pull-up device, and enhancement NMOS transistor used as a pull-down. This is the minimum criteria. Whenever this is satisfied, this is act as a corresponding NAND gate realization. So this is a very crucial point from this. So what is some of the conclusions? What happens is that when the ZPU to the sum of all ZPD is must be at least 4:1. So from this diagram, compulsory the impedances, okay, the impedance of all pull down networks, must be 4:1. 4:1. That means the impedance of all the pull down network must be 4:1. That means ZPU ratio of ZPD must be ZPD satisfies the criteria 4:1. Then only it acts as a proper inverter, then only it performs the basic up. It may be noted that not only one pull-up transistor it is required for the input of NAND gate stage, but also size of the pull-up transistor is also adjusted to maintain the required overall ratio. So here also not only consideration of the corresponding total number of devices, but the problem is that we need to adjust the size of the pull-up device is also, that is also very important criteria. So this requires a considerably large area than those of the corresponding NMOS transistor. That means if you want to maintain the corresponding ratio, compulsory size of the device is also changes. Size of the pull-up device also changes, right? Moreover, delay increases in a direct proportion to the number of inputs. If each pull-down transistor is kept minimum size, then each will represent a one gate capacitance at the input, and the resistance of the pull-down transistors will be in series. Therefore, n input NAND gates will have a n times that of the inverter. That means if you know that if the size of the NMOS transistor is going to be decreases, what happens is that it is also represented one kind of the capacitance associated resistance and capacitance. It is act as a one kind of the RC network. Therefore, it produces a time constant is nothing but delay is increases. This is nothing but inverter that is nothing but tau is nothing but delay. So T and gate is equal to n times that of the T inverter, right? Moreover, as a consequence of nMOS NAND gates are only used for whenever absolutely necessary for the output. Output is low when only necessary for the number of inputs is restricted, so that delay remain within the limit. So this is a conclusion regarding the nMOS transistor. I will explain in Telugu also. Okay na? So మనం ఈ nMOS transistor అనేది యూజ్ చేసి మనం NAND gate రిలైజ్ చేస్తున్నాం. ఈ NAND gate రిలైజేషన్ ప్రాసెస్ లో ZPD అనేది మనం పుల్అప్ డిప్లీషన్ మోడ్ nMOS ట్రాన్సిస్టర్ ని పుల్అప్ నెట్వర్క్ గా కన్సిడర్ చేస్తున్నాం. రిమైనింగ్ n ఇన్పుట్ nMOS ఎన్హాన్స్మెంట్ టైప్ యూజ్ చేసేసి పుల్ డౌన్ నెట్వర్క్ లో యూజ్ చేస్తున్నాం. సో మనం ఇలా యూజ్ చేస్తున్నాం అంటే కంపల్సరీ ఈచ్ అండ్ ఎవ్రీ పుల్ అప్ డివైస్ as well as a pull down devices also means it is nothing but one kind of a resistance and assumption తీసుకున్నప్పుడు it is a equivalent circuit that represent like this. Therefore ఒక నెట్వర్క్ ఇలా యాక్ట్ చేస్తుంది అంటే కంపల్సరీ అకార్డింగ్ టు ఓమ్స్ లా తీసుకున్నాం అంటే దీస్ ఇంపిడెన్సెస్ ఆర్ కనెక్టెడ్ ఇన్ ఏ సిరీస్ ఫ్యాషన్. Therefore overall impedance value is equal to n into ZPD. So from the according to voltage divider rule which considers as a voltage drop across this one is equal to source voltage VDD and voltage across of the corresponding transistor corresponding impedance divided by total impedance. This impedance plus pull up divider. So if you are this voltage must be less than that of the 0.2 of VDD. If you are substituting this, we will get the minimum criteria, that is nothing but ZPU by n into ZPD value is equal to 4 anos. So that is a minimum criteria. So delay is also increasing. So that means this nMOS enhancement NAND gate can be nMOS NAND gate can be only used whenever it is absolutely necessary condition. Endukante if the number of transistors are increases means that means if the number of inputs are increases, obviously the size of the device is also increases. Not only a ratio of the pull up and pull down transistor count, we can adjust the size of the pull up device is also very important to maintain the corresponding 4:1 ratio, right? So that is regarding the nMOS NAND gate realization.